when we have such a thing as the mathematics, matter, and mind harmony, what we need is a unifying metaphysical explanation. This powerfully implies that humankind must occupy an exclusive place of significance in the cosmos. Johannes Kepler was obsessed with harmony. Harmony of all kinds, aesthetic, which would be artistic and musical harmonies, but also intellectual harmonies, such as harmonies that are detected by pure mathematicians when they're working on their equations. But there was one harmony that was the driving force behind not only his life's work, but even his theology and his understanding of human society. This is the harmony that makes cosmic comprehensibility possible in the first place, makes the scientific enterprise a reality. We have three disparate parts operating in harmony when it comes to our comprehension of the universe. We have the abstract world of mathematics, these eternal, infinite truths. We have the material world on which mathematics beautifully maps so that we can do science. And then we have this aptitude of the human mind. Our minds have free will, and we have mathematical capabilities so that we can look at that material world using the immaterial world of mathematics and then carry out our scientific investigations. I have a two-part thesis for you today about cosmic comprehensibility and thus the existence of the scientific enterprise. The first part of my thesis is that this three-part harmony requires an uncanny harmony of circumstances that have no causal connection, and that's the really important part. We have three things happening together. All three are required, but there's no causal connection between these three things. One doesn't cause the other, in other words. I'm co-opting a word here that you may have seen before, synchronicity. Synchronicity is the idea of an acausal parallelism. Or you could put it more casually, a meaningful coincidence. In this case, an astonishing coincidence. And when we have such a thing as the mathematics, matter, and mind harmony, what we need is a unifying metaphysical explanation. The second part of my thesis is that this harmony, I've sometimes referred to it as a grand cosmic harmony. This powerfully implies that humankind must occupy an exclusive place of significance in the cosmos. But before I really get into the argument, I want to take you on a very, very brief tour of intellectual history. In my book, I unpack this over chapters. So if you're a history of ideas nerd like I am, then I would point you to the book. But let's look at just a very few highlights, and believe me, it pains me to only get to talk about these few. But here we go. The phenomenon of cosmic comprehensibility has absolutely fascinated great thinkers since the very beginning of what we call, properly speaking, the great Western tradition or Western philosophy. And in this artistic rendering, you see the great philosopher, the most famous of those we call the pre-Socratics, Pythagoras of Samos. He was an oral teacher. He left behind no writings, but schools were spawned based upon his oral teachings. So we do have evidence from the Pythagorean schools of some of the things that they believed. And one of those is key to my talk today, and that is they believed that number is in some way the essence of all reality. Not just the physical stuff that we can count and examine, but also there's something about the human mind that can grasp number in a very special way, something about the human rationality. Now, fast forward a few centuries, and we get to, actually, fast forward just a few decades, and we get to Plato. You've all heard of Plato, right? He's one of the holy trinity of ancient philosophy, Socrates, Plato, and Aristotle. Plato was the funnel through which Pythagorean thought went. And Plato loved this idea of the universe being mathematically rational. In one of his dialogues entitled The Timaeus, I highly recommend it, he said that when our cosmos was formed, it was a divine craftsman looking to a rational plan, a geometrical, a mathematic plan. And that is why we have this mathematically ordered and harmonious universe that we can observe with our senses. And he went even further, just like the Pythagoreans did, and said this harmony and order is reflected within the soul of man. That is how we are able to detect it in the first place. So we have the formation of what I refer to as the Pythagorean Platonic tradition in Western philosophy that we can trace all the way up to today, as you're going to see. But I want to just give you two really important examples. The gentleman there on your left, Philo of Alexandria, was an Alexandrian Jew who grafted this Pythagorean Platonic tradition about the creation into his Jewish theology. The big step that he took was to say, yes, there was a mathematical plan for the universe, but it has existed from eternity in the very mind of God. A little later, Augustine of Hippo, arguably the most influential Western theologian, adopted this idea as well. And he said, yes, it would even be heresy to say that something existed from eternity alongside God, so we must put this mathematical plan within the mind of God. Fast forward again, and we come to my hero, Johannes Kepler. Kepler was a devout Lutheran during a time when it was actually very difficult to be a Protestant Christian during the Counter-Reformation. And let me just give you a few bullet points on Kepler's idea of cosmic comprehensibility. First of all, I want to explain why Kepler, because we have this whole tradition already leading up through the Jewish and then Christian theologians. So why Kepler? Well, I'm going to tell you why. Kepler really represents the intellectual culmination of this Pythagorean Platonic tradition. In addition, he transformed astronomy. He is the pivotal figure between ancient astronomy and a sophisticated mathematical science, using all of his fancy mathematics that you probably learned a little bit about in high school. And incidentally, I always like to bring this up because it's not often mentioned. His cosmological model was superior to his contemporary Galileo's because Kepler used the elliptical orbits, whereas Galileo refused to give up the perfect circular orbits of Aristotle. And finally, we come to his beloved concept of harmony, the fitting together of disparate parts, and this pervaded and motivated his life's work. The famous Kepler biographer Max Caspar put it this way. He said, "This harmony gripped him with a ferocity even when he was still a young man, and it carried with him throughout his entire life." I'll give you a few quotes directly from Kepler himself. He said, "To God there are, in the whole material world, material laws, figures, and special relations of special excellency and of the most appropriate order." Here he's talking about the geometrical construction of the cosmos, but also the mathematical laws that he developed. first, second, and third laws of planetary motion. He goes on to say, those laws are within the grasp of the human mind. God wanted us to recognize them by creating us after his own image, so that we could share in his own thoughts. He goes on to say that geometry provided God with the patterns for the creation of the world and has been transferred to humanity with the image of God. For what is there in the human mind besides figures and magnitudes? Here he's talking about how we work from imagination in our investigation of the world, the imagery in our minds. It is only these which we can apprehend in the right way, and if piety allows us to say so, our understanding is in this respect of the same kind as the divine, at least as far as we are able to grasp something of it in our mortal life. For the divine counsels are impenetrable, but not his material creation. You see here this ancient philosophy of the two books of God's revelation. And as I sat here earlier this morning, I was delighted to see that in the first two stained glass windows, we have the Word and the world. And that's exactly what Kepler was celebrating. He said, as natural philosophers, we're like priests, but we're exegeting the book of nature. He said in his famous work that he considered his magnum opus, the Mysterium Cosmographicum, or the mysteries of the world. God, the creator, had the mathematicals with him as archetypes from eternity in their simplest divine state of abstraction. So if we have any Plato scholars in the room, you know that this is a very Pythagorean Platonic statement to make. I want to situate Kepler's metaphysic about cosmic comprehensibility in a little diagram that I think you might find helpful. At the top, we have the archetype, or the mathematical plan for creation that has existed from eternity in the mind of God. That archetype is made manifest in the material creation as a copy. And then image-bearing creatures, humankind, we can look to the copy, and because of our mathematical aptitudes and our sensory experiences of the world, we can get a little glimpse into the very mind of God by observing all the things that he has made. I hope that reminds you of some key scripture, such as Romans 1:20. All right, there's your little bit of intellectual history culminating with Johannes Kepler. We're going to leap forward again to what we could refer to as the physics revolution of the early 20th century. What I'd like to do is profile several Nobel laureates of 20th century physics, and I do this to demonstrate that this Pythagorean Platonic idea of cosmic comprehensibility and the things that must resonate, mathematics, matter, and mind, this was a huge topic of philosophical discussion, especially around this particular time in the history of modern science. Now, with the possible exception of the first one I'm going to show you, none of these were religious believers. And I don't have time to unpack why I'm sort of excluding the first one, but I just wanted to offer you that bit of information because these aren't Christians we're talking about. The first is Max Planck, and in his scientific autobiography, which was published posthumously, he made this statement that sounds so Keplerian to me. He said, "My original decision to devote myself to science was a direct result of the discovery which has never ceased to fill me with enthusiasm since my early youth, the comprehension of the far from obvious fact that the laws of human reasoning coincide with the laws governing the world about us." His contemporary and colleague Albert Einstein remarked on several occasions in interviews, in letters, in essays, that this comprehensibility is miraculous. He says the fact that it is comprehensible is a miracle. Even if the axioms of a theory, such as this theory of relativity, are proposed by man, the success of such a project presupposes a high degree of ordering of the objective world, and this could not be expected a priori. That is the miracle which is being constantly reinforced as our knowledge expands. Paul Dirac, Nobel Prize 1933. God is a mathematician of a very high order, and he used advanced mathematics in constructing the universe. To be clear, Paul Dirac here is using the word God metaphorically. Wolfgang Pauli, who I'm hoping to do some work on this year, Nobel Prize 1945, he said, "We must postulate a cosmic order of nature beyond our control, to which both the outward material objects and the inward images are subject." We then come to Eugene Wigner, Nobel Prize 1963. Famous essay. You can access this for free online. I highly encourage you to take a look at it. It's only 4 or 5 pages long, entitled "The Unreasonable Effectiveness of Mathematics in the Natural Sciences," published in 1960, written in 59, officially published in 1960. And he makes several very important points about this grand cosmic harmony. He says, "The enormous usefulness of mathematics in the natural sciences is something bordering on the mysterious. There's no rational explanation for it. It's not at all natural that the laws of nature exist, much less that man is able to discover them." We'll spring forward again to the contemporary conversation. We've gone from Pythagoras, and now we're landing on Penrose. Roger Penrose, Nobel Prize 2020. He says, "There is an extraordinary concurrence between the workings of the natural world at its most fundamental levels and sophisticated mathematical theory." So in interviews, in several of his books, and several of his peer-reviewed scientific papers, he discusses something called the three worlds, three mysteries problem. If you start at the top of the diagram, you have the Platonic mathematical world. Moving around clockwise, you come to the physical world. What I want you to notice is in between there's this cone shape. And what he means by that is that there's only a very small part of this infinite, abstract mathematical world that we use when we examine the physical world. And then it's only a small part of that physical world that gives rise to the mental world, meaning the human brain. And then with that mental world, with part of it, we're able to discover the mathematical realm, this abstract, eternal realm of truths. And he says that this is just a profound mystery because it's not a question physics can answer. Metaphysical questions demand a metaphysical answer. And so he chalks it up to permanent mystery. When presented with the solution of a transcendent mind, the idea that mind is fundamental to existence rather than just the material, subject to the laws of nature, his response, even up to very recently, has been, "I just don't know what to do with that." It doesn't fit within his metaphysic. All right, so now I've introduced you to the conversation, presented you to the fact that what we're dealing with is a rather large synchronicity, and it demands an explanation. So what I'll turn to now are some of the claims that are made in response to the presentation of this grand mystery. For example, well, humans have merely devised systems of mathematics to just fit the natural phenomena close enough, and that's how the scientific enterprise is made possible. I'd like to offer 2 responses to this. First of all, some of the mathematical systems in question were developed independently, meaning they had no known applicability in the natural sciences. And besides that, they were developed the way they were for aesthetic reasons. You may have heard phrases such as elegant mathematics. Yet, these same systems were later, and sometimes much later, discovered to be essential to scientific investigation. I want you to ponder that for the rest of the weekend, because that's magnificent and mysterious, and it cries out for an explanation. Here's an example for you: Einstein's theory of general relativity. When Einstein was developing relativity in the first few decades of the 20th century, he needed a non-Euclidean system of geometry in order to describe his theory of gravitation. And lo and behold, it turns out that the century before, roughly half a century before Einstein's doing his work, a gentleman by the name of Bernhard Riemann had developed exactly the type of non-Euclidean geometry that was essential to Einstein's work. Historian of mathematics Maurice Klein said it would have been a superhuman effort for one man to first develop a whole new system of geometry and then apply it to his entire theory of relativity. It just could not be done by one man in one lifetime. And so this was a fortuitous thing for the progress of modern science. Steven Weinberg, who just passed away actually in 2021, Nobel Prize 1979, in his book, Dreams of a Final Theory, he said, physicists generally find the ability of mathematicians to anticipate the mathematics needed in the theories of physics quite uncanny. It is positively spooky how the physicist finds the mathematician has been there before him or her. And again, another scientific materialist. Second response to this idea that we're just crafting mathematics to fit the science as we go is that mathematics maps onto the material world with such an astounding precision that it has even made successful predictions in fields such as particle physics, which involves intricate and very delicately balanced, elegant systems of equations. I'd like to give you a sensational example of this in action. Peter Higgs, Nobel Prize 2013. Back in the 1960s, Higgs is working with a team of colleagues to figure out a problem in the standard model of particle physics. And the problem was that according to their beautiful integrated system of equations, particles had no mass. But that doesn't make sense, because how do you get mass from constituents that have no mass? So Higgs and his team proposed this theory that all of empty space is permeated by a field with which particles interact to get their mass. Some liked it, some didn't, but the wonderful thing about it was it helped them preserve their beautiful, elegant system of equations, whereas just trial and error plugging numbers in to try to account for particle mass threw everything into chaos. So what we have here is mathematics being chosen for aesthetic reasons, and we have predictions being made based on mathematics, but no empirical support for this whatsoever. It wasn't for 50 years after this proposal that empirical evidence was provided by the Large Hadron Collider. They were finally able to test Higgs field theory, and on the 4th of July, 2012, you may have seen some of the science headlines about the God particle being discovered. They announced that a particle fitting the right profile had been detected in the Large Hadron Collider. I love this photo of Peter Higgs. I can just imagine how vindicating this felt to stand in front of the Large Hadron Collider in celebration of the discovery and in celebration of the Nobel Prize. So 49 years after his prediction, he wins the 2013 Nobel Prize in Physics. Here is a picture of Peter Higgs with the late, great Stephen Hawking. And I just want to offer you one comment that Stephen Hawking made about this discovery. Physics would be far more interesting if it had not been found. Congratulations to them both, but the discovery of the new particle came at a personal cost. I had a bet with Gordon Cain of Michigan University that the Higgs particle wouldn't be found. That Nobel Prize cost me $100. Here's another claim in objection to this idea that we have a legitimate metaphysical mystery on our hands. And that is, well, naturalistic evolution of the human brain has just produced the capacity for advanced mathematical computations. Here's my first response to that. The mental aptitude that's actually necessary for advanced mathematics, and I hope you can all relate to this if you took any advanced mathematics ever in your life, seems far beyond the alleged powers of natural selection. But don't take my word for it. Paul Davies, a physicist who I believe is still at Arizona State University, put it this way in his book, The Mind of God, and by the way, he is not a religious believer. One of the oddities of human intelligence is that its level of advancement seems like overkill. While a modicum of intelligence does have a good survival value, it is far from clear how such qualities as the ability to do advanced mathematics ever evolved by natural selection. These higher intellectual functions are a world away from survival in the jungle. He goes on, the mystery is that human intellectual powers are presumably determined by biological evolution and have absolutely no connection with doing science. Why should this be? Just why Homo sapiens should carry the spark of rationality that provides the key to the universe is a deep enigma. Second response, genuine rationality, which is required in mathematical reasoning and scientific problem solving, cannot be produced by material processes alone. So now we're stepping into the realm of philosophy of mind. Let me just give you a few bullet points. You can do multiple PhDs in this field. Let me just give you a few bullet points to whet your appetite. Neurochemical reactions. If all our cogitations are nothing but neurochemical reactions, there are some big problems for the scientific enterprise. First of all, instances of material cause and effect, which is what would be going on in the brain if materialism, or to use the fancy philosophical term, physicalism is true, that means there would be no free judgment. Can't have free will if everything going on in your head is just a domino effect adhering to the laws of nature. So no free judgment, and free judgment is required for genuine rationality. Secondly, a neurochemical reaction cannot adhere to an immaterial law of reason, a mathematical law, a law of logic. Chemicals can't decide A or B based on, oh, well, I have to choose A because A is logical and B would commit a fallacy. Chemicals don't do that. They don't have awareness. They can't choose. And finally, a neurochemical event cannot be about something. In philosophy, we call this the problem of intentionality. And it simply means that matter, physical stuff, isn't about something. It can be a medium, but it is not the message itself. So those are just three rather large problems for this idea that if we are nothing but matter, if everything that goes on inside of our skull is just chemical reactions, we would not be able to do science in the first place. Don't take my word for it. Another scientific materialist, Sean Carroll, in his book, The Big Picture, put it this way: there is no direct evidence for free will, and it violates everything we know about the laws of nature. in order for libertarian freedom to exist, it would have to be possible for human beings to overcome the laws of physics just by thinking. So he gets it. Sean Carroll gets it. It makes me wonder how he thought this book was produced, actually. So we circle back around to this idea of cosmic comprehensibility. Mathematics, the material world, and the human mind working in concert so that we can think God's thoughts after him, so that we can make scientific discoveries. So, to use my fancy word again, we have this synchronicity, this astonishing set of coincidences that do not have causal connections between them. And this demands a metaphysical explanation, remember, because it is a metaphysical problem. And Kepler's idea of archetype, copy, and image, which has carried on since Kepler in Christian theology, not in these words, but in concept, is satisfying, it's unifying, and it really gives us a solution that covers all the bases. I'd like to end with a very short poem that Kepler wrote himself about this grand cosmic harmony. As God the Creator played, so he also taught nature as his image to play, the very game which he had played before her.